So this is the first lecture on types of analysis in FEM. Actually, this part is very important whenever you use the ANSYS software uh, for many type of the analysis. So why should we understand the types of analysis in FEM? Suppose somebody is asking you to do the analysis of pressure vessel, you should be able to select a proper type of analysis. Suppose somebody is asking you to do the analysis of a spur gear, so you should be able to select a proper type of analysis. So for this purpose, the concept of different types of analysis must be cleared with all of you. We will wait for 2 minutes. Let other students come and attend the lecture. Okay, it is okay. Now we will start. So, in case of FEM analysis, actually, most of the expertise they are many times confused to select type of analysis. There is some technical problem. Please wait for 5 minutes. Please wait for 5 minutes. There is some technical problem. Am I audible to you? Am I audible to you? Okay, thank you. Hello. Hello. Hello, can you listen to me? Okay, I will start now. Rather, I will show you just PPT or PDF file. My video is not getting synchronized. Huh. So we will start now. So once again, I will repeat a few points. In types of analysis, we have to select a proper type of analysis in order to increase the analysis in different softwares. And the selection of proper type of analysis, it must be done well, because if you select a wrong type of analysis for a particular problem, it will not give you expected results. That is the issue with most of the expertise or learners, beginners. So this is important part in CAE, computer aided engineering. One video we have uploaded on youtube.com. It is related to concept of static analysis. There I have told you the static analysis and its applications. In short, I will repeat what is the static analysis and its application. Before going to this dynamic type of analysis, this screen shows the types of dynamic analysis. In short, I will tell you the static analysis and its a use. Static analysis, that is used for dead loads. Suppose for a long time one component is subjected to a constant load or a dead load, that can be used in static analysis. So for example, during a construction or building a construction, we use the different types of beams, and these beams are lying on each other for years and years. So there we have to implement the static analysis. So dead loads are dead loads are applied in the static type of analysis. Suppose a car is standing and it is not moving, but the self weight of that car is acting on uh, chassis frame. So chassis frame must be analyzed statistically. So this is the expected. Take an another example of static analysis. A pressure vessel, it is just steady, it is not moving obviously, and liquid is stored in a pressure vessel at a high pressure, and that pressure is also constant. So there you have to use the static analysis. So this is expected in static type of analysis. And there are types of static analysis such as a linear static analysis and non-linear static analysis. So there are types, but linear analysis and non-linear analysis, the main difference is that the material properties. Non-linear static analysis consists of non-linear material properties. So there will be a stress versus strain uh, curve that we have to input in a software, CAE software. But in case of a linear static analysis, we have to just enter elastic modulation of Poisson's ratio in the software, and we can go ahead with the static type of analysis. So all these things are related with the CAE softwares. So I request all of you to study different non-linear properties of a structure. I request you to study different non-linear properties of the structure. So I am repeating this sentence because it is most important for non-linear analysis. Suppose some groups are taking analysis on um, a universal testing machine, and in universal testing machine you want to break the component, and you want to check its strength. Someone is interested to check its static strength. So in that case you must have the data available, non-linear data of the component. You must have the data related to non-linearity. You must have the table of stress and strain, and the stress and strain, it must not be linear. So this data you must enter in a ANSYS software or any CA software. There you can go ahead for the statics type of analysis. So this is the advantage of statics type of analysis. Now we will go ahead little bit. Now we will turn towards a dynamic type of analysis. So first of all you should understand, so what is a dynamic analysis? What is dynamic analysis? The dynamic word itself indicates that uh, dynamic analysis is used for different types of dynamic loads. Dynamic analysis is used for obviously different types of a dynamic load. Obviously some students may have confusion that, sir, this component is stationary, so we should go for the statics type of analysis. But rather you should consider the static or no movement of that analysis. You should focus on the dynamic loads acting on that component. Many times I show this to the student. Suppose this wall, obviously wall is stationary, constructed wall is stationary, but the loads acting on that wall are dynamics. Or bridge, that structure is stationary, but the many vehicles daily travels through that bridge. So in that case you should focus on the dynamic loads acting on that bridge. So there you have to select dynamic analysis. This is expected. So again I am repeating, so don't be in the confusion that, sir, component is stationary, so that I have selected static analysis. Component may be stationary or may not be stationary, but if loads acting on the components are varying with respect to time, then you should select a dynamic type of analysis. That is expected. Again I am repeating, the same statement. Please understand this. Many MTech students also and PhD students have this confusion in their mind. They are doing the project on the component which are stationary, but they don't know how to select which type of analysis they should select. Component is stationary, but loads acting on the components are changing with respect to time. So you have to select the dynamic analysis. So I hope that you have understood this basic fund of dynamic type of analysis. Now we will move ahead with the types of analysis. So in finite element analysis, there are three types of basic dynamic analysis. First one is a modal analysis, then transient response analysis, and then harmonic response analysis. So these three types of analysis are basic types, and later on this transient type of analysis is little bit improved. Then shock spectrum analysis came into picture, then transient thermal type of analysis came into picture, and many more types of analysis came into the picture. But these three types of analysis are very important when you learn any software or related to CAE, that is ANSYS software. So I will repeat the list of the software first of all. CAE softwares, first one is the ANSYS software. Nowadays it is used worldwide. Then LS Dyna is one software, it is also used worldwide. Also um, Adam is a one software which is specially used for automobile components, analysis of automobile components. Uh, then Abacus is one software which is specially used in Roman countries. Abacus. Then Hypermesh is one software which is specially used for meshing of the component. In the last lecture, these students were not there. In the last lecture, I have explained the concept of finite element analysis. There I have explained the concept of meshing also. You may watch that lecture on the YouTube, which is available. After this lecture, you may go online and you can watch that lecture and solve the corresponding quiz. So hypermesh nowadays it is not mostly used because ANSYS software is improved a lot. Its features are improved a lot. So for meshing purpose, you do not need a separate software. For meshing purpose, you do not need a separate software. Directly you can use the ANSYS software. So these are the some basic softwares related to CAE. One among the best software is a Nastran. Is a good solver for giving the finite element analysis results. The results you get in the ANSYS solver, same results you will get in the Nastran solver. So Nastran is a good solver that is also recommended in the many industries. Also NISA is one software. It is also a solver like ANSYS software, but ANSYS provides the good guide user interface for modeling the different components also. But other softwares they only provide the solver features. Only results can be calculated, but the different CAD models are very difficult to draw in those software. So therefore ANSYS has become more popular in nowadays. Now first of all we will discuss a model type of analysis. Model type of analysis is used for finding out natural frequency of the component. So I am repeating my statement. Those students who are present, please put your roll number after 5 to 10 minutes. So I will come to know that you are watching the lecture. Just this is checkup. I am knowing that you are interestingly watching this video lecture. But just put the lecture so I will get the feedback that all are online. So model type of analysis is specially used for finding out natural frequency of the component. So very first thing, why we are interested to know the natural frequency of the component? Obviously natural frequency must be more in order to avoid the resonance of the component. Obviously take an example of helicopter blades. So if helicopter blades are rotating at high speed, helicopter blades are rotating at high speed, and what happens, the rotor frequency, because of rotation of that helicopter blades, one frequency is generated, and that frequency may be matching with the other components of helicopter, and there may be a failure of helicopter components. So this may cause accident. So therefore every component of helicopter must have the high natural frequency, and it must be greater than the rotor frequency of the helicopter blade. So natural frequency is very important to avoid the resonance. So while designing the component itself, you must be able to design the component in such a way that natural frequency must be more. Root k by m, it's a formula, stiffness with respect to a mass in the root. So root k by m is the formula for the natural frequency, and you must keep the natural frequency more. Modal analysis. See, I am repeating some statements again. Modal analysis must be done for all automobile components. I am repeating this statement two times. Modal analysis must be done for all automobile components. Modal analysis must be done for all automobile components. Now there may be a question in your mind, why sir it is necessary? Because in automobile component most of the components are rotating at high speed, high rpm, and these components cause on rotor frequency, and if the frequency goes more than the natural frequency of other steady components, there are the chances of failure. So sometimes fatigue type of failure is also there, but for any kind of such failures, first of all, natural frequency is the important parameter that must be taken into consideration. So whenever you design the component, after designing, first of all you go for the modal analysis in ANSYS software. Right now you have not learned in ANSYS software. See, after start of the college we will take the tutorial. Also I recommend you to watch the different videos available on this YouTube channel, which are giving the basic and advanced information of all type of analysis. So I recommend, so after this lecture you can go for the watching modal analysis on this YouTube channel. Our alumni students are also watching this channel many times, so you can go through and you can watch it. Also for installation of ANSYS software, I will share you one tutorial of just 2 minutes. You can install the ANSYS software by sitting at home also. It is not necessary to come at the college in this pandemic. So you can install and you can start practicing also. I will guide you for installation process also. Now modal analysis, it's a governing equation, that is also important point. See, in the theory of machine you have learned a governing equation of all types of behaviors: dynamic behavior, static behavior, f of t sine omega t. So here f of t indicates the force changing with respect to time. Force is the function of time, and sine omega t is the sinusoidal nature of that force, and that is for harmonic type of analysis. Transient response analysis, mx double dot plus cx dot plus kx is equal to f of t. That equation is used for transient response analysis. And modal analysis, it's a governing equation. Now I will show it to you. It's a governing equation. Directly I will come to the governing equation. This part you can study in the notes itself, but I will directly come to the governing equation. Is it visible to you? Mu double dot plus ku is equal to 0. Is it visible? Hello, am I audible to you? Is it visible? So here mu double dot, you instead of you can type here x also. So it indicates an acceleration and u indicates the displacement. So here kx is equal to 0. So here you can observe from this equation, so there is a no force. There is a no force in this type of analysis. Please understand this very important point in the modal analysis. There is no external force applied in this type of analysis. Mx double dot plus kx, or you can type there u also, and is equal to 0. So this body is vibrating naturally, therefore there is no influence of external force. I am repeating, this body is vibrating naturally, therefore there is no influence of a force. So here where m indicates mass, k indicates the stiffness of the component. I want to tell you here, stiffness is defined as the force with respect to deflection. F by x, you might have learned this formula in theory of machine or machine design 2 or 1. So natural frequency of the component can be improved by adjusting stiffness and mass of the component. Natural frequency of the component can be improved by adjusting mass and the stiffness of the component. I am repeating my statements. Listen, because it is important to avoid the resonance failure due to the resonance. Natural frequency can be improved by adjusting mass and the stiffness. As I told you, root k by m is the formula. But in modal analysis, actually nobody is recommending to you apply the external forces. So external forces are not there. You have to just type the frequency, you have to just type the density of that component. One more thing, whenever you do the modal analysis, transient analysis, or harmonic analysis, any kind of dynamic analysis, there must be a parameter called as a density. Some students in the last year or previous year students, they used to do the analysis on ANSYS software. They used to go for elastic modulus, Poisson's ratio, but they were not preferring density parameter. So density parameter is very important in ANSYS or in any kind of the dynamic analysis. So if you want to do its proper analysis or accurate analysis, so density must be there. Why density should be there? Because density is a mass upon volume. Density is a simply mass upon volume. So it consists of dependency on the mass. So if density is not there, software will not give you the results of modal analysis. I am repeating the statement. If density you do not enter in the software will not give the analysis of modal results of modal analysis. It may be transient or it may be harmonic. So modal analysis is very important in all type of the components which are vibrating naturally or to improve its natural frequency. So component may be stationary, may not be stationary, it may be moving, whatever the forces are acting on it or forces may not be acting on it. But whenever the component is stationary, you must improve its natural frequency. So to check this phenomena, you have to do its modal analysis. Yeah, how to do its modal analysis. Suppose one student has designed the spur gear and its a module is 5, module is calculated 5, and afterwards you have to draw, because on the basis of module itself you are going to draw spur gear obviously, and you have to draw its CAD model. After drawing the CAD model, you have to go in ANSYS software, enter in ANSYS software and do its modal analysis and calculate its natural frequency. Now some students may have doubt, sir, what is the natural frequency, because lot of readings we are watching on the software. So the frequency at which the deflection is more, I am repeating, please listen this carefully, because afterwards you have to do the software courses like ANSYS CATIA Pro E. Also for final year project you may do the modal analysis. After modal analysis, there will be the table which gives thousands of reading. After that, thousands of frequency, which frequency is the natural frequency. So the frequency at which the displacement is more or displacement is maximum, that should be considered as a natural frequency in ANSYS software. Suppose you have got the readings of 1000 frequencies and 1000 deflection. So at which frequency deflection is more maximum, that you should understand, and that can be considered as natural frequency. So this was a little bit importance, and natural frequency that works everywhere. You should focus on calculating and improving the natural frequency always. So this was a basic and simple introduction of modal analysis. Actually it is a vast topic, but in short period of time I had tried to explain you. Now we will turn towards the transient type of analysis. What is transient type of analysis? So Before explaining its application, we will learn, first of all we will understand its governing equation. Actually here u, small u, uh, this notation is used. You can consider this as x also, because you have learned this equation. Suppose I take this as a mx double dot plus cx dot plus kx is equal to f of t. All the parameters are functions of time. All the parameters are function of time here. So here m indicates mass, this is acceleration, this is velocity, and this is a deflection. I am repeating, this is acceleration, this is velocity, and the deflection. So transient analysis so transient analysis is always used for vibration analysis. Listen carefully, because the loads acting on the components are not specific. The loads can be changed at any time without giving any warning. So for that purpose, transient analysis is implemented. I am repeating my statement. The loads acting on the component are changing with respect to time. They are not constant. Their nature is also not specific. Their nature is also not specific. Say at first second 10 Newton load is applied. After 9 seconds the load on the component is 100 Newton. After 1000 seconds the load on the component is 50,000 Newton. So this is the drastic change in the application of load, and there you should prefer the transient type of analysis. See, most of the students have confusion in their mind. Sir, I want to do the vibration analysis. So vibration analysis, this word does not exist in ANSYS software. There is a transient analysis, there is a dynamic analysis, explicit dynamic analysis. So types of analysis are defined and output of that analysis will be a graph of the vibration. So if you want to do the vibration analysis, you can go for the transient response analysis. So what you will get in the transient response analysis, that we will see now ahead. Where it should be used, obviously on all types of automobile component, aeroplane component. So where loads are varying continuously, in these types of component loads are varying continuously in all types of these components. So for example, ship hulls, take an example of ship hulls. On the ship hulls or ship, waves of the oceans are applying the pressure, and this pressure is changing with respect to time suddenly. Sometimes there is a less pressure, sometimes there is a medium pressure, sometimes there is more pressure, and this is happening again and again. So in this case, you have to select a transient type of analysis. Take an example of dynamic analysis of bearing, which is nicely suitable. Dynamic analysis of a bearing. Again I am repeating. So if you want to do the dynamic analysis of the bearing, you can directly go for transient type of analysis. There you have lot of scope for getting the minute results in the depth. Because if you see, why we are preferring the dynamic analysis, the loads acting on the bearings are changing with respect to time suddenly. So there is a lot of scope for dynamic analysis in bearing component. So all components which are rotating, for example, analysis of the solid shaft, hollow shaft, propeller shaft in the automobile, and different types of the bars, rods, and even automobile body also, in chassis also, I recommend to go for the transient response analysis. I remember 5 years ago our students used to manufacture the solar vehicle in our college, and there was a lot of scope for their analysis. I remember there we had done the dynamic analysis on their chassis, and later on they had gone for the manufacturing of the solar chassis. So solar chassis was initially modeled in the CATIA software or PROE software, and then it was analyzed by using transient response analysis. So that project had become successful. But whenever you want to do a design of any automobile component, you must go for the transient response analysis also, because take one example. Suppose one vehicle is moving on the road and suddenly it passes through the speed breaker, so loads on the automobile is changed. Vehicle is moving with fast speed, approximately 120 km per hour, so pressure on the vehicle body is changing continuously. You cannot deny this factor. So their body is must be analyzed by using transient type of analysis. So these things must be taken into consideration for transient response analysis. Along Apart from this, there are lot of applications of transient type of analysis. See, one more thing, ceiling fan at our home, you can take it for the dynamic type of or transient type of analysis. Wheel rims, you can take it for dynamic type of analysis. Some biomedical application, artificial hand, artificial foot, so other artificial components are designed. All robotics component must be analyzed by using transient response analysis. I am repeating, if you are doing the project on a robotic arm or any kind of artificial organ of the human body, you can go for use of transient type of analysis. In our YouTube channel, there are lot of tutorials available related to the dynamic type of analysis. You can study, and even advanced tutorials are also kept on our YouTube channel. We had taught this to your alumni or your senior students about the dynamic type of analysis. We had a lot of studies we had done in our college, and projects are also done, and that is available on youtube.com. There is good advantage, you can go through the channel, you can learn the advanced tutorial and you can implement these tutorials in your project. So dynamic analysis, that is transient response analysis, has a large scope. You can implement it anywhere. Rather, I recommend to every student, whatever the project you do, you must go for the transient response analysis. For any type of the project, it may be a simple project or the critical project, you should go for the transient type of the analysis, transient response analysis, and it is a must nowadays. See, in design department, whenever component is designed, it is analyzed by using transient response analysis. And many times there are also iteration. In the first iteration, results you may not get as per the expectation. Second time analysis done, third time analysis done, and so on. Almost 100 times analysis is executed in order to get the expected results of the analysis. And even though if you do not get the expected results, once again the design of the component is changed. Once again design of the component is changed, and this is happening. In fact, this is happening everywhere. And nowadays also ANSYS provides a good feature to do this iterative analysis procedure. ANSYS software provides the opportunity features for iterative analysis procedure. So you can go there. So after learning the basic, you can understand what is the iterative procedure in ANSYS software later on. So first of all, you try to install the ANSYS software and go through the basic tutorials of ANSYS through our channel. Now we will move ahead in harmonic type of analysis. Huh. Regarding the output of this transient analysis, modal analysis, and harmonic analysis, I'm willing to discuss separately in the next lecture. see how the graphs are generated for different types of analysis, that we will discuss. Now we will see the harmonic type of analysis. Obviously there must be a sine omega t, f of t sine omega t. There is a corresponding change. This equation will remain same for harmonic analysis. This equation will remain same for harmonic type of analysis, but there is a little bit change. F of t sine omega t, f of t sine omega t must be there here. So mu double dot plus cu dot plus ku is equal to f of sine omega t. This is the corresponding change in the harmonic type of analysis. Why this is the change? Because the force applied on the component is harmonic in nature. It is having the sinusoidal nature. So you can see this graph here. So this response, so this wave is the sinusoidal wave, and even though output of the harmonic analysis is also sinusoidal, the vibrations generated in the harmonic type of analysis, these are also in sinusoidal nature. So where you observe the sinusoidal motion, you can use the harmonic analysis. Or constant motion. I am repeating my statement. Constant motion. Please remember this. So for example, the constant motion. You take an example of camshaft. Take an example of crankshaft, ceiling fan. So these all are rotating at the constant speed. These all are rotating at the constant speed, and there you can go for the harmonic type of analysis. So whenever the component has the constant motion or sinusoidal motion, or it is subjected to the periodic loads, you can implement the harmonic type of analysis. So its output results are we will discuss in the next live session. This is just a part 1, types of analyzing FEA part 1. Like this we are going to conduct second and third part. So there I will explain in the depth, and also I will explain some tutorials live also. Now you are requested to go to the Moodle software and solve the corresponding quiz. Yesterday I had uploaded, and write the assignments. So thanks for attending this live session.